one-step fraction equation. Topic 18. Now, just like yesterday when we went over solving one-step decimal equations, we took a moment to just be reminded of what our decimal operations were. And then we went over our integer operations. We're not going to go back over integer operations today. If you did what you were supposed to do yesterday, you have those reminders in your notes. Plus you have your flow chart and all of your notes for operations with integers inside of your notebook. But we are going to go over fraction operations today, since we are now working in fractions. So, at the top, fraction operations. Remember, when you are adding or subtracting fractions, you must have like fractions. The denominators have to be the same. That's the only thing you had to remember about adding and subtracting. You have to have like fractions. When you were multiplying, you must have fractions. You can't multiply when you have whole numbers, mixed numbers. You have to have fractions. So if I had 12, then I would put a 1 under it and make it a fraction. If I had a mixed number, remember I would multiply the denominator and the whole number, add the numerator, which would give me the new numerator, then I keep the old denominator and turn it back into its improper fraction form from its mixed number. Now, once I have fractions, whether I had to change it to an improper fraction or I had to change it to a whole number with 1, once you get those made, you multiply across top. And then you multiply across bottom. Now remember, it's at this point, before you do that multiplication, that if you can reduce inside of the problem, top to bottom, or diagonally top to bottom, but you cannot reduce side to side. But if you can go ahead and reduce something top to bottom or diagonally, you can go ahead and do it, and it keeps those numbers small. We went through those when we were doing fraction operations as a review. And then when you are multiplying Again, you must have fractions so we take our time to turn them, but then we copy the first one change the division sign to a multiplication sign and flip the second one. After you've done that, you now have a multiplication problem, and you multiply across top, multiply across bottom. And again, if you can reduce on the inside before you start multiplying across top and bottom, that's the place to do it. So quick review of our fraction operations, because now we've also got integer rules that are playing a part. Example 1. If I had 2/3 x is equal to 5. Remember, they are one-step equations. I'm only going to have to undo one thing that's been done to it. So, what has been done to x? Always the first question you ask. It has been multiplied by 2/3. We're going to undo it by dividing by 2/3. What I do to one side, I have to do to the other. This reduces down to 1x. So I've isolated that variable on the right or the left side. And now I have to do the problem that's on the right side of the equal sign. This is not a fraction, so I put a 1 under it. So now I have fractions. Now my dividing fractions up here says, I copy the first one, I change the division to multiply, and I flip the second one. It's at this point, if anything inside can be reduced, I reduce it, but it can't. So now I just multiply across top. 5 times 3 is 15. 1 times 2 is 2. So 15/2 is the answer. If this were a gridded response and you just had to type your own answer in, 15/2, it would take it, you would be right. But if it were a multiple choice, they're probably not going to put a multiple choice answer in an improper fraction form. 2 will go into 15 7 times with 1 left over, and you keep your denominator. So it's 7.5. This is probably the most involved problems that you will do, is solving 1 and 2 steps with fractions, just because it's so much to remember at one time in one problem. You can come try and find it. Example 2. X plus -9.5 is equal to 11 1/4. Now, the one thing that I can say about the EOG is they're very good at not giving you fractions that make you think a lot. They give you those benchmark fractions that you're supposed to know, like 1/2, 1/4, 3/4, 2/5, 4/5. They give you those things that you're supposed to already have memorized that you can change to decimals quickly and easily, mentally. So this is definitely something that looks like what you would see on your EOG. Because you know that 1/2 is 0.5, you know that 1/4 is 0.25. If you had to quickly turn that into something you could work with, if you forgot your fraction rules, then that's something that you could do. This is the middle of your balance. What has been done to x? I have added negative 9.5. So I'm going to subtract a negative 9.5 from both sides. When I do that, that cancels out, leaves x by itself. And this one is keep, change, change. Anytime you have a subtraction, it is keep, change, change. Now you have two positives, so you're supposed to add. That's 11 1/4 plus 9 1/2. We have to have like fractions in order to add. What I do to the bottom, I do to the top, so that makes it 9 2/4. 1 plus 2 is 3, keep the 4. 11 plus 9 is 20. So the answer is 20 3/4. Because they were both positive, it's a positive 20 3/4. You changed it into 0.5 and 0.75 to work, or 0.5 and 0.25 to work it out, you're still going to get 20.75 as your answer, which is the decimal equivalent of 20 3/4. Because you keep, change, change in every subtraction on your integer notes. And when we're over here, the only way you're going to subtract integers when you're adding is if those integers are different signs. These are the same sign, so you add. Any other questions? Got to learn those integer rules. I can promise you 8th grade don't want you if you don't know them. Because they jump right in expecting you to already have them memorized and working with them proficiently. They don't want to spend time having to reteach you something that you were supposed to already learn, practice, and be able to do proficiently before you leave here. And since it was introduced in quarter 1, you've got 3 more quarters to perfect it before you get to 8th grade. Example 3, if I had x divided by 1 3/4, and that's equal to 7 5/8. This is the center of my balance. What I do to one side, I have to do to the other. What I ask myself is, what has been done to x? It has been divided by 1 3/4. What's opposite of divide? I'm going to multiply both sides by 1 3/4. That cancels and leaves x by itself on this side. I isolated the variable on this side, and so now what I have to do is solve this problem, and that's my answer. What I said at the beginning when we were going over our fraction rules, you cannot multiply mixed numbers. You have to have fractions. So at this point, you're going to turn 56 plus 5 into 61, keep the 8. And this is 4 plus 3 is 7. Keep the 4. We don't flip this one. That's only when we're dividing. We cannot reduce anywhere. So now what we do is multiply across the top. 7 times 1 is 7. 7 times 6 is 42. And 8 times 4 is 32. If this had been a gridded response, like I said, you're having to type in your own answer. Don't try to make it harder than it is. Type in 427/32 and move on. Of course, check it first to make sure that it's the right answer. But if you don't have to take this and turn it into a different form, every time you have to do more to a number is more chance for you to make a careless mistake. So, again, if it's multiple choice, they're not going to leave it in this form. This is an improper fraction. So they're going to take the numerator, divide it by the denominator. 32 will go into 42 one time. That's a remainder of 10. Drop the 7. 32 will go into 107 3 times. 3 times 32 is 96 with 11 left over. So that's 13 and 11 32nds. That's the mixed number equivalent. 13 and 11 over 32. I'm going to pass out the practice for you, and we're going to do one of them on your sheet together. Dolores and Sierra, you only do even numbers. Mark out number 19. We're not going to talk about that right now. You can solve that two different ways. You can kick that variable off of the fraction and look at it as 9/65 times k, or you can solve it in 2 steps. Because we're only looking at one-step equations right now, and there's already enough problems there for me to assess that you know what you're doing. Just mark number 19 out. But let's look at a subtraction problem. We haven't looked at one of those. So example 4 is going to be number 2. M is subtract 1.5 is equal to negative 5/4. And again, benchmark fraction, 0.5, something that you definitely are going to see. 5/4 you'll see. These are some very easy fractions, low benchmark. I mean, you can expect it. Plus, they've even kept this one as an improper fraction for you, so you don't have to get something else into an improper fraction as you're working. But this one is a adding and subtracting one, so we're going to be more concerned with, are the denominators the same? What has been done to x? It has been, I have subtracted 1.5. So I'm going to do the opposite, which is to add 1.5. That reduces down to 1 and leaves M on that side by itself. And now I have to come over and look at what's going on that side. This is an addition, so I don't have to keep change. So if I know it's addition, then I go back to my addition flow chart and I look and it asks, are the signs the same or different? Are the signs the same or different? That's a positive, that's a negative. They're different. So I'm subtracting. When the signs are different, you subtract. We went over and over why. On the number line, if you're going in the negative direction and you have to turn around and then go positive, you're backing up. You're canceling out sets of 0 pairs as you are going back over a number you've already been over. So when you're going in different directions, it's subtraction. So we're going to take 5, I'm going to put 1.5 on top because it's bigger when you're looking at value right now. And then I'm going to put my 5/4. And I want this in fourths because when we went back and looked at our fraction rules to add or subtract, we're actually subtracting because these are different signs. We're turning them into fourths. 2 times 2 is 4, so 1 times 2 is 2, that's 1 2/4. So now we have to subtract. Can I take 5 from 2? Do I want to even leave it in this form? I can still do it. I'm going to have to borrow from the 1 and make it 4/4, and it's going to end up being 6/4, and I take 5 from the 6. But if you go ahead and turn this into 4, we're going to 5 one time. 1's left over, keep the denominator. Then if I turn this back into a mixed number, then I can clearly see where my subtraction is headed without having to borrow here because I can't take a 5 from a 2. So that would have been the easiest way to solve this one. So now 2 minus 1 is 1. Keep the 4. And 1 minus 1 is 0. The higher 1 is positive, so my answer is positive. So it's positive 1/4 is the answer for your number 2 on your sheet. Any questions about that one? Those of you that I asked to do just the even numbers, you're 2, 4, 6, 8, 10. Everyone else, you're working on all of them. We have crossed out number 19 as a group. Any questions? As you get to working, if you have a question, raise your hand. And I'll come around and help you. The video will be in Google Classroom. Whenever you are taking the remainder of the sheet home, if you need to watch the video again, you can do that. That's a resource that's available to you.